Hi, this is Fatima. Here let us discuss about what is this repository pattern and its benefits and an example to understand this repository pattern in ASP.NET Core. Before proceeding to this video, watch my previous video where we have discussed about SQL Server configuration with Entity Framework code. Repository pattern. Repository pattern is an abstraction of the data access layer. That is, it hides the details of how the data is exactly saved or retrieved from the underlying database. The details of how the data is stored and retrieved is in the respective repository. When coming to its benefits, the code is cleaner and easier to reuse and maintain, and it enables us to create loosely coupled systems. This repository pattern supports the unit testing project. By the way, it helps us to replace a real repository with a fake implementation for testing purposes. Let us understand these things with an example. This is an ASP.NET Core web application we have created with a simple empty project template. Let us use this in order to understand the repository pattern and how it helps us to store and retrieve data from the SQL Server database using Entity Framework code. The repository pattern contains interface as well the actual repository. If you see this repository interface, iProduct repository interface specifies what operations are supported by the repository. For example, get product by simply ID and get products, all the products, and add operations, and also the data required for each of the operation, that is the parameters that need to be passed to the method and the data the method returns. Here in the first get product parameter we are passing is ID and we are returning the product. This iProduct repository simply contains what it can do and does not specify how it does that. The implementation details are in the sample product repository for that interface. Now this iProduct repository supports get product by simply passing ID and get all the products as well addition. In addition to this, let us add updated product as well the deleted product operation. With the product, it will return the product and the operation is update. Let us pass the product that contains changes, that is the modified product. Product modification. Okay. And for the delete operation, it returns the product, deleted product. Operation name is delete. Passing ID that needs to be deleted. That's it. Let us add the details of how these operations are implemented in this sample product repository class that implements this iProduct repository. So press Ctrl period, implement interface. So it automatically adds a signature for delete and update. Let us check this product list by the incoming ID. So product list dot first default method to check whether the product ID set p dot ID equal to incoming ID. and assign this to the product. Product object, so that if this product is not equal to null, let us remove the product from the product list. So let us have the check. If the product is not equal to null, then we are going to remove that product from this list. So product list dot remove method, let us pass the respective product. And let us return the removed product. Let us also have the implementation for update method. Let us check this modify product ID is equal to any one of the product present in the product list. So let us check product list dot first dot default product ID equal to the incoming modified products ID. If it is same, let us create a product object and assign it to that. Now we have to check if the product is not null, then we have to take the corresponding product from the product list and assign its property to the modified products property. So now if the product is not null, let us assign the modified products property to its property. So product dot name equal to the one that comes in property. Product dot price modification dot price. So now we updated the product. Let us return this updated product. So now we have the CRUD operations, and this specifies the implementation that stores and retrieves the product from an in-memory collection. Let us have another repository pattern for the SQL Server implementation. So let us add one more repository class that provides implementation for this iProduct repository. Right click on this model, add new item, class, name it as SQL product repository. And let us have the implementation here that stores and retrieves the product from the SQL Server database using Entity Framework code. Inherit from I product repository interface, and let us create the constructor. And we have to pass the application DB context that we have already created. Application DB context object. Press control period. Implement interface. Control period on this context in order to create and initialize the field context. Now let us provide the corresponding implementations. Now let us do the code changes for the add product. Context dot products dot add. Let us add this incoming product. And let us save the changes to the database. Save changes. And let us return that product. And for the delete operations, let us find the product by ID. Context dot products dot find by the incoming ID. If it is present, we have to delete it. And assign this to a product object. If this product is not null, we can remove that. It's not equal to null. Then we can remove that product from the context. Dot remove the product whose ID is same as the incoming ID. Once we delete it, we need to save the changes to the database. Context.save changes. And let us return those product. And let us return that product. Let us return the product. Find it by ID. That's it. In order to return all the products, let us have the changes. Return all the products. Context.products. That's it. Let us have the changes for update operation. For update operation, let us attach the modified product to the context. So let us use the attach method and attach the modified product to it. And let us assign this to the variable product. Now we have to mark the state of the product as modified. Let us do that. Product dot state equal to entity state is present in Microsoft Microsoft dot entity framework core dot entity state dot, let us mark it as modified, and let us save this context object context dot save changes. That's it. Now we have made the respective changes for the CRUD operations in order to save and retrieve data from the SQL Server database using the entity framework code. Now if you look at this home controller in our application, this ASP.NET Core dependency injection system injects an instance of this iProduct repository. Now we have two implementations of this iProduct repository. One is the sample product repository as well the SQL product repository. Then how does the application know which implementation to use? The answer to this is we have to make change in the startup class. Here if you notice, we use the sample product repository registered with iProduct repository. So as of now it will use this in-memory collection. If you want to use the SQL product repository, we can replace this with SQL product repository. We already have discussed the difference between the singleton, scoped and transient. So let us use the method add scoped. We have changed this to add scoped because we want the instance to be alive and available for the entire scope of the given HTTP request. So for the another new HTTP request, the new instance of the SQL product repository class will be provided and it will be available throughout the entire scope of the HTTP request. It is clear now that if we want our application to use a different implementation instead, all we need to change is the single line of code in the startup.cs file. This is why the applications are loosely coupled. In future, if you want our application to work with Oracle, we can use this instead of the SQL Server. We can implement an Oracle repository that knows how to read and write to the Oracle database, and we can register the Oracle repository with this dependency injection system. That's it. With these changes in place, now let's run the application and see the output. At this moment, we are shown up with an exception, can't open the database product DB requested by the login. This exception occurs because we do not have the database created yet. Let us see how to create the database in our next video. Hope you enjoyed this video. Our next video is about Entity Framework Core migrations. Thank you.